talk about drinking water. Usually when I start talking about water or something in front of my wife, she just rolls her eyes and says, stop listening. No one's ever interested. But yeah, so drinking water, where does it come from? How is it treated? What all our water infrastructure system takes place here. So yeah, so where's our water come from? It comes from the American Bottoms Aquifer. What you see here is a geological map. I know it's kind of tough to see here, but you kind of see on the right side, you'll see the Cahokia, or on the north side, you see Cahokia. Right side, you see a big envelope in the middle. There's a nice big sand seam, about 100 feet deep, going the whole length basically of that map from top to bottom, from Cahokia on the north all the way down to 270 on the south side there. That sand seam, like I said, is 100 feet deep. We have 9 wells scattered throughout that area to different well fields that pull our groundwater out of that American Bottoms Aquifer. It's actually been said, talking to EPA and other resources, that this is what, if everything dries up throughout the entire United States, this will be one of the last aquifers that will still have water. It's not fed by the Mississippi River, but it all acts as one hydrologic unit, basically. So it's we have one of the best groundwater systems basically in the country. So we're very blessed to be where we're at and be able to pull our groundwater out of that system. How do we treat it? As the water gets pulled up out of the ground, it has a lot of iron and manganese in it. It's a hard water. It actually is a brown type. It has actually sand, real fine sand in it. So we're going to, first what we do is we want to try to precipitate as much of that iron and manganese out. How do we do that? First, actually, once it comes out of the well field, goes through an aeration process and gets chlorine and potassium permanganate mixed in it, and it precipitates that iron and manganese out into a basin. That oxidation process kind of helps the initial hardness come down. We then do ion exchange. What is that? That's water softener. Typical water softener, but we've got 9 of them, and they're easily we fill up this entire room, so, in 2 different treatment plants. After that, it goes through the filtration process, continue to filter, pull out what's left of that iron and manganese process. Goes into another 1 million gallon storage tank, gets disinfected, fluorides added, and the water stabilized. Now, what do I mean by stabilized? That's an ortho and polyphosphate mixture that we add to the water to help stabilize the water. You may have heard some out in the news lately, orthopolyphosphate is big with lead. It's a huge thing that we do to add to make sure that there's no lead issues in this community. The orthopolyphosphate not only coats any of the piping, steel piping, but it keeps any iron and stuff what's left that could be aggressive to the water, keeps it stabilized in the water. So you could have a house that's 100% lead piping and having this stabilization process and having our groundwater, there's no concern. So that's part of what we do to stabilize the water. You see that we can pump 8.9 million gallons a day out of our treatment plant. We use about 4.17 on average. And for 1 year, we pumped 1.5 billion gallons of water to the city, to SIUE, to Plant Carbon. So what, after it gets pumped and treated, what do we got? We got 171 miles of water main throughout the city, coming from the treatment plant and distributed throughout the entire city. We got a sample of the water main here that we've since pulled out. How do we get that water through there? We got 2 booster stations. You may know one on M Street, one off of South University Drive. That's kind of hidden, but that storage has 1.67 million gallons with pump systems that pump and pressurize and pump it to our 2 elevated storage tanks. You know, you see them off behind Cloverdale subdivision and off of Gerber Road. That's another storage capacity of 1.75 million gallons. See how many valves, how many hydrants, and how many customers we have there. 3,598 valves, 1,530 fire hydrants, and about 9,800 customers. We've got to exercise all those valves annually. We've got to operate our hydrants as we're flushing. We've got a very dedicated crew of water operators and servers that help us keep this going. So there's a lot going on rather than just thinking you turn on the faucet and it all comes up. So how do we know what we told you it was 1.5 billion gallons of water. We got these water meters, and we also meter their water and charge $7.79 per 1,000 gallons. So think about that. Think of your little glass. That's pennies on the dollar compared to what you're buying a bottle of water for. This is 1,000 gallons of water for $7.79. That meter charge of $7 or $9.76. That's going to be going to replace old, wonderful, positive displacement meters. Basically, it's as simple as you can get, really. Water comes in one side, spins the disc. Water comes out the other side. As that disc spins, it counts. What happens when they get old? They get old, they get rusted, they don't want to move. We always love it when someone calls and says their meter's spinning too fast. That doesn't happen. We'll be more than happy to come out and replace your meter and call and say it's spinning too fast, because we will replace it with one of these nice new fancy meters. No moving parts, electromagnetic meter. We're in the process. We've already got a contract underway with Core Main to install what's called automatic metering infrastructure. We're going to have 2 antennas, one on each top of our water tower. And Tim, and how long have we been trying to do this for? So we're finally to that point where we're getting this. So all we'll have to do to water or to see how much water you're using, click on the mouse. We'll be instantly see if your toilet's leaking, if you're using any water, so that we'll have alerts set up so that if you're using water continuous at a continuous rate from midnight to 2 a.m. when there should be no water, we're going to see that. We're going to be able to alert the customers that you've got a water bill. So the water conservation that this is going to save the city and its residents is just going to be incredible once we get these all installed. First phase of installation will actually start here in another month or 2. So you'll be seeing a lot of headlines on that coming out in press releases for installing these new meters. But that's what essentially what the bi-monthly meter is for. Now, what is your $7.79 per 1,000 gallons by? Obviously, we've got to treat that water. We've got to maintain our system, but we also have to replace our system. That's been a huge push for us here in the last few years, and huge thanks to Hal for seeing and being accepting of getting this push to start replacing our capital system. What you see here on this map is every project that we currently have funding for. Almost 2.5 miles of water main being replaced in the next year. I showed you there's 171 miles of water main. Some of that water main is approaching 120 years old. Cast iron mains like this one here. 4-inch cast iron main. This is underneath Vandalia Street. Completely blew apart. You can see how corroded it is on the inside. This one was about 120 years old when it broke. So that's been our main push to get some of that infrastructure not only replaced, but upsized for fire protection. There's not much water you can push through a 4-inch water main. So we're not only replacing old infrastructure, but making sure that infrastructure is capable of handling all the fire mains of the community. That's what you got. It's 2.5 miles of water main this year. So if we're replacing 1% of our system, so that means once every 100 years, you're replacing your water mains. So we got to replace over 1.7 miles of water main a year. And we're finally on that target of doing that now. But keeping in mind, we also still have to keep up our water treatment plant. We're going to also be having a large water treatment plant project coming up in the next few years to add and take down 70-year-old filters and softeners that have far exceeded their lifetime. We work with Veolia, North America is our operators on our water and sewer treatment plants, and they've done a tremendous job to help keep those up and going. But they have reached their lifetime, probably the next 3 years, 3, 4, 5 years, be doing a very large water treatment plant project to keep that up and coming. So going back to the water rates, I know probably a lot of you have seen the last 2 years that increase. That increase does go exactly to what I just mentioned. These water main improvement projects and water treatment plant projects. I'm sure I'm forgetting something about our distribution system and water system.
That's sending it out, talk about bringing it back.
Talking about bringing it back, yeah. About 212 miles of sanitary sewer. 36 lift stations that pump it throughout the city, or pump it back to the treatment plant. Our treatment plant, sewage treatment plant's on New Pogue Road there. I'm sure you've seen it if you go out to 255. Treat about 3 million gallons a day. I just say, well, where's that loss? Well, SIU UV feed, they've got their own treatment plant, one carbon, and then people washing their cars or water main breaks, fire hydrant use. So we do treat a little bit less water at our sewage treatment plant. You probably don't know, but our sewage treatment plant actually pumps and discharges all the way to the Mississippi River. So we physically have a pipe from Edwardsville that goes all the way to the river. It's treated by, it's first treated, settle out.
Do you want to interrupt your change?
No, I'm rambling now.
Could you explain why you flush hydrants?
Yeah, so flushing out, as I mentioned, with the iron manganese and then use that ortho polyphosphate to keep everything suspended in the system. Well, when you keep that iron and manganese suspended in the system, it can settle off if you don't have water moving. So what we want to do is get that water moving. We do it 3 times a year, 4 times a year, different sections, yeah. But we want to get that water moving and get that whatever could settle out of the water. So we get fresh water. We want to keep a chlorine residual. I say chlorine residual. We have to inject. Obviously, there is the possibility of bacteria growing in your water. Chlorine is used to kill that bacteria or to prevent it from growing. So we inject chlorine in our water. That is our main form of disinfection. A lot of you, I don't know if anybody lives in Glen Carbon here, but there you switch over, they use chloramines instead of chlorine. Go into that. So you may notice a taste or smell difference with the Glen Carbon water. But their water comes from surface water. It has organics in that water. With you use free chlorine and chlorine with organics, you have a total trihalomethanes. It's a byproduct of chlorine disinfection and organics. So you don't use chlorine with surface water. You use chloramines, which is an ammonia-based disinfectant. But it also comes at the disadvantage of some taste and odor smells. And you also have to flush your system more than what we have to flush it. Actually, and you have to flush it with free chlorine to potentially kill any growing organics in that water. So, the Illinois American Glen Carbon system may seem more efficient, and going through America, there is some drawbacks to that. I was going through water and more about sewer.
Mike to the Mississippi.
Yeah, questions? That's true.
Can you explain what happens when there's boil water?
Yeah, boil water. So boil water is issued anytime your water pressure drops below 20 psi in the water mix. So when the water drops below 20 psi, we issue the boil order, and that can happen from a main break, from a pump going out, anything out of the ordinary, essentially. What does that mean? You got to boil any drinking water, any water for use for basically anything. You still shower with it, any cooking water has to be boiled, and it's everybody always says 24 hours. It's not. It's 24 hours when we first take the test to when we get our first results back on whether boil water should be lifted. So it's a minimum of 24 hours. It could extend until we get a good passing sample. I say passing sample. Say we got a water main break. We then, once we get it up and running, we have to take a bacteria sample to see if there's any bacteria in it. If there's no bacteria in it, we'll know in 24 hours, we lift the boil.
And the boiling would kill the bacteria.
Boiling, yeah, kills the bacteria. Yeah. There's a bunch. So. Go ahead.
Okay, did you have a problem with, there was a shortage of chlorine or something earlier?
That was making the news round. We had not had any issue. It was kind of more of the cool thing. We have our chlorine arrives in 1 ton cylinder, so the size of this gas chlorine. So we have not had any supply.
What is the front, like, what are you starting with first when you start replacing models? What's the area or?
Yeah, so background map here. So this is the older part of town. We've replaced some of our water mains here. And as we're doing, we're obviously digging up the roads, we gotta replace the roads, go back, replace all the meter grids, service lines. But we really are looking at where our main transmission mains are, our larger water mains, and where we can get, if we replace the main, where we get the most benefits from first, replacing old infrastructure and pushing fire flow. You see Buchanan and East Kansas and East High on this map, and Chapman. Those are water mains that are undersized, and by upsizing them and replacing just as they're 100 years old, we now have fire flow to schools, to downtown area. It creates a loop from East Union all the way down to Vandalia, gets larger water main with more pressure out towards 157. So it's we're not just picking and choosing
Right,
which
but like
water.
those things are for residential.
So yeah, these are all residential water mains.
Are you doing businesses or residential?
We have to go route by route. When I say route by route, we've got 7 different routes throughout the city, basically. What was routes are really chosen by our water meter readers as they walk around. So based on really how they walk through the subdivisions over the last 60, 70 years.
I think we're doing a third, it's a 3-year program.
Yeah.
We buy about $1 million of these every year for the next 3 years, and they are installed by our people and by private contractors.
Right.
As quickly as we can by different areas.
The first couple routes are going to be actually based around where our 2 water towers are at. We want to make sure that we're getting a good read, a good signal to a tower, that we're not installing it someplace and we're trying to figure out why it's not working or what's going on. We're going to install it in a place that we know we should have good signal, good working areas, and expand on.
And a lot of this technology is very similar to what Ameren, you probably Ameren's.
Right, that's what I was thinking of.
System, so it's just, the public sector is just lagging behind the private sector, so there'll be benefits to us, upgrades or other. The 2 meter readers we have currently, this full time, that's only do 3 meters. We're gonna have them go back and actually help maintain the system, like Brad mentioned, flushing hydrants, exercising valves, doing that type of thing.
So luckily our city hasn't sold off its water system, American water. Is there still, I'm sure there's gotta be a great deal of pressure on those guys. And as an engineer looking up, does it look like the city has a mind to keep their water system? Or do you see them eventually sell
And
From a staff side of it, we would not recommend the city sell the system.
it? Well, you know what?
We're not gonna get a vote, there's one voting member here, but from a staff side, we would not recommend, at the time, at this juncture.
just having our own treatment plant, it gives us so much more control over our rates, over our quality. Just
I'm sure they're knocking on the door with a big check. Yeah. Yeah.
It's been going on for 2 decades at least.
Hey, Ryan, for those of us that have water meters in our basement, will you be moving those outside when you do?
No,
this?
they will, the meters will be replaced in place, so we'll be working on basically knocking on doors, dropping a flyer off, saying, please schedule a meeting with us, and we'll get it replaced.
You kind of mentioned some of the work that goes into the posting things. Makes sense. What's the useful life on that? Is there a lag in what, I get there probably is a lag. How much of a lag is there to sit on?
Yeah, we do have a current water main that we've seen stamped in the 1800s, it's got a stamped date on it, and it's still in use.
What's the useful life if all is well?
If they say design life, yeah, if you're talking to the designer, they're gonna tell you 50 years, but they've all lasted
But
100
they
years.
all know.
A lot of the infrastructure on the north end of town in particular, it dates back to early 1900s or late 1800s. So, in the historical perspective, that's, pre-World War I.
Right.
Some of the infrastructure at our treatment plant, in the filters and softeners, what we call Plant 1, for World War II era equipment. They're still in operation. They're in failure mode right now.
I always make sure to point out, this is an iron water main, because it was before steel.
Are you putting in steel now?
We're putting, PVC.
Okay. And then,
Some of our larger-
How large are
Yeah.
they?
Usually, 6 to 12 inch. It just depends on what it's feeding. Is it more of a transmission main, like North Main Street? We wanted to make sure we were never gonna have to dig up that, or touch that water line for 100 feet. Just what it actually is, a ductile iron, water main, that's 12 inch.
I live in Flint Park, and they went from Edwardsville water to somebody else, and then the case
That's
was
all I heard.
immediate, not for the better.
It is harder water, it is chlorine instead of free chlorine. With it being a surface water, there's gonna be a lot of differences.
But to kind of go on, would we ever sell the system? I mean, we put so much money into our system and we have it programmed now with proper rates. Before I was in office, we were charging $4.25 a gallon for those 1,000 gallons. Now it's up to $7.50 because that money is being put into infrastructure. To give you an example, every time we want a road to be done, so we get a lot of calls, can you please fix this road, fix that road? St. Louis Street one, the one that comes to mind, that was about $1 million project, and just the water portion only was $440,000. So when you look at a road to be replaced or repaired, plan on at least half of that cost being below the road, being sewer lines, the storm sewers, sanitary sewers, and the water. All those homes on St. Louis Street and any road project we do, it's a brand new connection. It's a brand new water line and brand new feeder lines all the way into the meter to go to the house.
And I'll touch back on the water rates too. It's so hard to compare like our community to anybody else's community with water system rates. It's, you can say, well, I used to live here, I paid this much, how come I'm being charged this? Well, maybe the age of their system's a lot less. Are they treating surface water? Are they treating groundwater? There's just so many different variables in every distribution system treatment plant that you really can't say, I'm paying this much in this community, why am I paying this much? It's just so particular to each setup and how it is.
And the average user uses 4,500 gallons a month.
Yeah.
About
4,000.
times 750, and that's about what the water bill, and then your sewers on that, sewers a little bit more.
How many communities full Aquifer?
Just us.
Just
Directly right by us. Collins, I mean, the Aquifer does go further south to Collinsville pulls out of it. But I mean, right where our well fields are, it's not like Wood River has wells set up by us and they pump all the way. They've got their own wells up by them. And there's no effect from any of the other communities.
Yeah, in my time here, I don't remember like an import time where we had to ration water. Is that because the Aquifer level drops, you monitor?
Treatment process. That's from, we weren't physically able to treat enough water to push through the system. That's how, just during the summer hot times, so many more people watering their lawns, washing cars, and water demand just skyrockets in hot weather. And our water treatment plant can't physically, yeah, the aquifer, we could probably pull 3 times as much out and it'd be fine.
We have more capacity now since Flint Park.
That's correct.
Not really a question, but 2 comments. Number one, to get better perspective, kind of understanding how old the downtown water main system is, try to get some grapes Our Rotary Club was a huge thank you to Eric Williams. Without his real blessing here this spring, we met there at the college in second. It was really his pull and decision and budgeting and understanding of that allowed us to get that really cleaned up down there. So we can hold it this year. So Eric, big round of applause. Years through the previous mayor.
I'll end on good news. Musan is recording this session, Brian, so you should be able to play this for your wife.
Yeah. I'll turn it on.
Gonna love
it. Start reading books. I would like to just thank Mayor Al, former Mayor Al Patton, SJ, former Alderman Walk, and you guys. This is the reason, we're here, because you guys, and allowing us to do what we can do for our district.
Do it well.
Anything else? Thank you, Ryan, Garrett, and Hal.